we continue reading through the electrical safety student manual. Section 6, Safety Model Stage 2, Evaluating Hazard. How do you evaluate your risk? Risk is the chance that injury or death will occur. After you recognize a hazard, your next step is to evaluate your risk from the hazard. So remember now, the hazard is the thing that can go wrong, and the risk is the chance that it will affect you. You will be harmed, things will go wrong. Alright? Hazard is the object or the situation that can lead to an accident that can cause harm, and the risk is the chance of it happening. Obviously, exposed wires should be recognized as a hazard. If the exposed wires are 15 feet off the ground, your risk is low. However, if you are going to be working on a roof near those same wires, your risk is high. The risk of shock is greater if you will be carrying metal conduit that could touch the exposed wires. You must constantly evaluate your risk, so you must make the right decisions. Combinations of hazards increase risk. This is a short circuit, is a low resistance path between a live wire and the ground, or between the wires at different voltages, called a fault if the current is unintended. Alright, now when you have a short circuit, you theoretically have a zero resistance. Every conductor has some resistance, but theoretically zero. So the current that would flow is theoretically infinite, but in reality an extremely high current flow, right? Which causes the wire to get red hot. You have a big spark and you hear a loud explosion and sparks go flying. Now, combinations of hazards increase your risk. Improper grounding and a damaged tool increase your risk. Wet conditions combined with other hazards also increase your risk. You will need to make decisions about the nature of hazards in order to evaluate your risk and do the right thing to remain safe. Right? There are clues that electrical hazards exist. For example, if a GFCI keeps tripping while you are using a power tool, there is a problem. Don't keep resetting the GFCI and continue to work. You must evaluate the clue and decide what action should be taken to control the hazard. There is a number of other conditions that indicate a hazard. So let's look at those conditions. Tripped circuit breakers and blown fuses show that too much current is flowing in a circuit that a fault exists. This condition could be due to several factors such as malfunctioning equipment or a short between conductors. So you have two conductors touching each other. It could be that they're touching each other when the cord is bent out of shape at a certain angle, or whenever a door is turned and it presses against the cord, or for some other reason, right? It may be continuous or it may be intermittent for those particular reasons. It happens when there is movement of another object. Again, I'm pressing against the cord. Now, you need to determine the cause in order to control the hazard. An electrical tool, appliance, wire, or connection that feels warm may indicate too much current in the circuit or equipment or that a fault exists. You need to evaluate the situation and determine your risk. An extension cord that feels warm may indicate too much current for the wire size of the cord or that a fault exists. You must decide what action needs to be taken, right? A cable, fuse box, or junction box that feels warm may indicate too much current in the circuit. A burning odor may indicate overheated insulation. So you smell something burning, probably like plastic or rubber burning. You know that there's a problem there. Worn, frayed, or damaged insulation around any wire or other conductor is an electrical hazard because the conductor could be exposed. Contact with an exposed wire could cause a shock. Damaged insulation could cause a shock, leading to arcing or a fire. Inspect all insulation for scrapes and breaks. You need to evaluate the seriousness of any damage you find and decide how to deal with the hazard. A GFCI that trips indicates there is current leakage from the circuit. First, you must decide the probable cause of the leakage by recognizing any contributing hazards. Then you must decide what action needs to take place. So, any of these conditions or clues tells you something important. There is a risk of fire and electrical shock. The equipment or tools involved must be taken out of service. You will frequently be caught in situations where you need to decide if these clues are present. A maintenance electrician, supervisor, or instructor needs to be called if there are signs of overload and you are not sure of the degree of risk. Ask for help whenever you are not sure what to do. By asking for help, you will protect yourself and others. Summary of section 6. Look for clues that hazards are present. Evaluate the seriousness of the hazards. Decide if you need to take action, and don't ignore signs of trouble. So, remember those clues that you have to look for. You must always look for clues that hazards are present, right? An 18-year-old male worker with 15 months experience at a fast food restaurant was plugging a toaster into a floor outlet when he received a shock. Since the restaurant was closed for the night, the floor had been mopped about 10 minutes before the incident. The restaurant manager and another employee heard the victim scream and investigated. The victim was found with one hand on the plug and the other hand grasping the metal receptacle box. Whoa. His face was pressed against the top of the outlet. An employee tried to take the victim's pulse, but was shocked. The manager could not locate the correct breaker for the circuit. You see the importance of knowing exactly where the circuit breaker and the main switches are, so that you can reach it very quickly or let train your workers so that they know exactly where the circuit breaker or the main switch off is located, right? The manager, could not locate the correct circuit breaker for the circuit. He then called the emergency squad, returned to the breaker box, and found the correct breaker. By the time the circuit was open or turned off, the victim had been exposed to the current for 3 to 8 minutes. The employee checked the victim's pulse again and found it was very rapid. The manager and the employee left the victim to unlock the front door and place another call for help. Another employee arrived at the restaurant and found the victim no longer had a pulse. The employee began administering CPR, which was continued by rescue squad for 90 minutes. The victim was dead on arrival at a local hospital. Later, 2 electricians evaluated the circuit and found no serious problem. An investigation showed that the victim's hand slipped forward when he was plugging in the toaster. His index finger made contact with an energized prong in the plug. His other hand was on the metal receptacle box, which was grounded. The current entered his body through his index finger, flowed across his chest, and exited to the other hand, which was in contact with the grounded receptacle. To prevent death or injury, you might recognize hazard that take the right action. If the circuit had been equipped with a GFCI, the current would have been shut off before injury occurred. The recent mopping of the floor increased the risk of electrocution. Never work in wet or damp areas. Know the location of circuit breakers for your work area. We are now at section 7. We will look at section 7 in a different video.